These are the notes for lesson 13.2, part 3, radian measure and arc length. So when we did our unit circle activity, we talked about one last thing that we were going to add to the unit circle, and that's radian measures. The definition of a radian measure of an angle is the length of the arc on the unit circle that is intercepted by the angle in standard position. So I want you to think about the circumference of the circle. If you remember from geometry, the circumference is 2 pi r, and that's all the way around the circle. In the unit circle, if r is 1, if we plug in 1 for r, then we just get 2 pi. So the circumference of the unit circle is 2 pi. If we think about in degrees, if we go around the whole circle in degrees, it's 360 degrees. So if we go around the whole circle in radians, think about that as the arc length, it would be the same as the circumference of the unit circle, which is 2 pi. So again, all the way around the circle in degrees is 360, and that is also 2 pi radians. So therefore, 2 pi is equal to 360 degrees. We're going to use this to figure out how to convert back and forth between radians and degrees. So if 360 equals 2 pi radians, then I want you to pause the video for a second and figure out what 180 degrees would be in radians, 90 degrees would be in radians, and what 1 radian would be equal to. So we're going to pause the video, see what you can come up with for those three. The first one is 180 degrees. If we know that 360 is 2 pi, we know that 180 is half of that. So half of 2 pi would just be pi. So 180 degrees is equal to pi. Same with 90 degrees. We know that 90 degrees is 1/4 of 180 degrees. So 1/4 times 2 pi. We can cross cancel, so we get pi over 2. So 90 degrees is the same as pi over 2. And the last one, 1 radian, if 360 equals 2 pi radians. If we divide that by 2, we get 180, and that equals pi. Remember, this is pi times 1 radian, so if we divide by pi, then we get 180 degrees over pi is equal to 1 radian, and that would be approximately 57.3 degrees. Whenever we're talking about radians, we usually do it in terms of pi. You will never see decimals. So the conversion for converting from degrees to radian, you're going to multiply by pi radians over 180 degrees and simplify. So for our first example, we have 60 degrees. Remember, to convert this to radians, we're going to multiply by pi radians over 180 degrees. So if we multiply this through, we get 60 pi over 180. 60 divided by 180, we can simplify that to 1/3. So our answer is pi over 3. So our answer is pi over 3 radians. For part B, we have 135. So again, 135 times pi radians over 180 degrees. Again, if we multiply this through, 135 divided by 180 is 3/4, so we get 3 pi over 4. And the last one, again, if we multiply by pi radians over 180 degrees, we get 39 pi over 18. And if we simplify that, we get 13 pi over 6. So our final answer is 13 pi over 6. So again, to go from degrees to radians, we just multiply by pi over 180. So in the first part, we were converting from degrees to radians. Now we're going to talk about the opposite. So if we're going from radians to degrees, we're just going to flip our fraction and multiply by 180 degrees over pi radians, and again simplify. So for part A, if we're going from pi over 4 to degrees, we're going to multiply by 180 over pi radians. Now remember that pi over 4 is in radians as well. So we are going to cancel out, or cross cancel, pi, We can also cross cancel our radians. So that just leaves us with degrees. So that's why our answer ends up in degrees. So then we're going to take 180 and divide that by 4 to get 45 degrees. So pi over 4 is the same as 45 degrees. For part B, again, remember this is 7 pi over 10 radians. So we're going to multiply by 180 degrees over pi radians. Again, our pi's cancel out, so do our radians. We can also cross cancel our 10 and our 180. If we divide 180 by 10, we get 18. So we're left with 7 times 18, which is 126. So 7 pi over 10 is the same as 126 degrees. And the last one, if we have 4 radians, remember we can write this as a fraction over 1. We're going to multiply by 180 degrees over pi radians. In this case, our radians cancel out, but we don't have a pi to cancel out. So we're just going to multiply 4 times 180, which is 720. So 720 degrees over pi. And we can go ahead and divide that out. It's approximately 229.2 degrees. So again, to convert from radians to degrees, we multiply by 180 over pi radians. Now below, the following unit circle has all the degrees and radian measures for each angle and shows the coordinates for each point. If you remember from the previous sections, x is the cosine of theta, y is the sine of theta, and tangent is y over x. So now, like we did before with degrees, we can also find different trig functions or solve them using the unit circle with radians. So you're going to have to flip back and forth to this page looking at the unit circle for the next examples that we look at. The next part of our notes is trigonometric functions and radian measures. So you're going to use the unit circle to find the exact value of each trig function. So we're going to have to flip back and forth to the unit circle. You're going to do just like you did with degrees, only now we're looking for radian measures. So the first one, we are looking for the sine of pi over 4. So I want you to flip back to your unit circle. And I want you to find pi over 4 on your unit circle. You'll notice it's at the 45 degree mark. Remember, when we're looking at sine, sine is the same as our y value. So if we look at pi over 4, our y value there is the square root of 2 over 2. So the answer to the sine of pi over 4 is square root of 2 over 2. And again, that's the y value. For part B, we're looking for the cosine of pi over 2. Remember that cosine is an x value. So again, I want you to flip back to your unit circle. I want you to find pi over 2. You'll notice that pi over 2 is our 90 degree angle. So the cosine is going to be 0, because again, that's our x value. Now for part C, we're looking for the tangent of 2 pi over 3. So remember that tangent is y over x. So we're going to look for our y value and our x value for 2 pi over 3. So again, flip back to your unit circle. 2 pi over 3 is 120 degrees. Our y value is the square root of 3 over 2. And our x value is -1/2. Now remember, when we're dividing, it's the same as multiplying by the reciprocal. So the square root of 3 over 2 times the reciprocal of -1/2 is -2 over 1. So we can cancel our 2's. And we get negative square root of 3. So the tangent of 2 pi over 3 is negative square root of 3. For part D, we have the sine of 7 pi over 6. Again, sine is our y value. So if you flip to your unit circle, find 7 pi over 6. You should notice it's at 210 degrees. Again, we're looking at our y value, which is -1/2. So sine of 7 pi over 6 is -1/2. I want you to pause the video for a minute. I want you to find E, F, G, H, I, and J. So you're going to go E through J, flipping back and forth to your unit circle, finding the exact value for each trig function. Now you should have answers for E through J, so let's go ahead and check them. E, you are looking for your x value at 4 pi over 3, which is negative 1/2. F is another one of our tangents, so 3 pi over 2. Remember, this is y over x, so our y value at 3 pi over 2 is negative 1. Our x is 0. We cannot divide by 0. You'll get an error if you type it into your calculator. We know that we can't divide by 0. So this one's going to be undefined. And later on when we graph trig functions, we're going to talk about what that looks like on a graph as well. Part G, we're looking for your y value at 5 pi over 3. So that should be negative square root of 3 over 2. H, for cosine, we're looking for our x value, which is negative square root of 2 over 2. For letter I, 2 pi. Again, tangent is y over x. Now in this case we have 0 over 1. 0 divided by 1 is just 0. So the tangent of 2 pi is 0. And the last one, J, sine of 5 pi over 2. Now 5 pi over 2, or 5 over 2, is 2.5 pi. Now we know that 360 degrees is 2 pi, so we're going to go another half. So this is the same as pi over 2. Again, we're looking for the y value because it's sine, so that would be 1. So again, we're just flipping back, looking at finding our radians on our unit circle and figuring out which value to use. The last section in our notes is arc length. The arc length formulas depend on which type of angle measure you use, and the letter S is used to represent the arc length. So if we look at our unit circle here, remember the radius is r, and then theta is the angle that we're using, and S is the arc. So this is the arc right here, the arc length. So if the angle theta is measured in degrees, then our formula to find the arc length is theta over 360 degrees times 2 pi r. So again, degrees, notice we have 360 degrees in our formula. If the angle of theta is measured in radians, we're going to have the same formula, only we're dividing by 2 pi instead of 360 degrees. Now if we look at this one here, our 2 pi's are going to cancel out. So in radians, our formula is just S equals theta times r. So depending on whether in degrees or radians, that will determine which formula we use. So for example A, we're finding the length of each arc described. So we have a circle with a radius of 5 and a central angle of 100. Notice we're in degrees, so we're going to use our first formula with degrees. So S equals theta, or the angle that we're working with, is 100. So 100 divided by 360 times 2 times pi times the radius is 5. So we have 100 over 360, which can simplify to 5 over 18. We have 2 times 5, which is 10, so this is 10 pi. So we have 50 pi over 18. Now 50 divided by 18 can be simplified to 25 over 9. So the arc length is 25 pi over 9. And if we're talking about the arc length, we usually leave it in terms of pi. We don't multiply it out to get a decimal. For part B, we're finding a circle with radius 7 and a central angle of 3 pi over 4 radians. Now notice we are in radians this time, so we're going to use theta times r. So S, our arc length, is 3 pi over 4 times 7, which is 21 pi over 4. We can't simplify 21 fourths, so we're just going to leave it as 21 pi over 4. So again, depending on whether we have degrees or radians, that will determine which formula we use to find the arc length. Remember, the arc length is the curve of that arc.